Okay, this is the second part of graphing. So we are on page 24. Alright, so if you look at this graph here, the first thing you always want to do is analyze it as much as possible before you start graphing. So you can see here that x is not equal to 1, and we'll figure out the range later. The vertical asymptote, since nothing cancels with the numerator, it is the same place. Horizontal asymptote, the top degree is 1, the bottom degree is 2, so this is y equals 0. There's no hole because nothing cancels. X-intercept is when the numerator is 0 of a reduced function. Because nothing cancels, so this is going to be 0, 0. Y-intercept is when x is 0, that's also going to be 0, 0. So it's going to be a little strange graph, but let's go ahead and put everything we know on there. Okay, x equals 1. Well, if you recall from, chapter 5, you might say multiplicity 2, but in this case, it doesn't really matter. The multiplicity doesn't matter in the asymptote format. Y equals 0 is the horizontal asymptote. And then we have a point at 0, 0. So that's not giving us a lot of information on how this graph is going to look like. So I'm going to have to put in more points. So I'm just going to choose a few because I actually don't know how this graph looks like either. So I'm going to put in maybe -2, -1. And let's try 2 and 3. Because I'm not quite sure how this graph is going to curve. Okay, so let's put in 2. So you get -2 over -2 minus 1 squared. That's going to be, the negative, just make it positive. That's -2 minus 1, which is -3. Squared is 9, so 2 9ths. -2, 2 9ths. So very small number somewhere here. Put a -1. -1 over -1 minus 1 squared. That is 1 over -2 squared. That's 1/4. 1/4 is, let's see, 1/4 compared to 2 9ths. Okay, so 1/4 is a slightly higher. I'm not quite sure what is going on here. I'm going to put one more point in just to be sure. I'm going to put in 1/2. Double check. So this is going to be -1/2 over 1/2 minus 1 squared. So this is -1/2 over 1/2 minus 1 is -1/2. -1/2 squared is 1/4. Alright, this is where you have a complex fraction and you gotta simplify. So just take out your skills from the last few weeks. You want to multiply by the least common denominator, or this is just one fraction over one fraction. You can just multiply by the reciprocal. So that's going to be -2. Okay, so this is at -2. So then I know the graph is going to look something like this. It's not going to go back up anymore because remember that you're thinking of the asymptotes as if it's a magnet. So this is not going to go below the horizontal asymptote. I've pretty much only seen a graph cross the horizontal asymptote once. It's not going to go back and forth. So it's just going to cross it once. If it already crossed, then this part here is not going to cross again. And it's just going to be drawn to the horizontal asymptote like a magnet. So you can pretty much be sure it's just going to go flat. Alright, let's check to see what's on the right hand side of the vertical asymptote, because like I said before, vertical asymptote is going to be a real distinct, like a wall, like nothing crosses that. So let's try this one. 2. That's going to be -2 over 2 minus 1 squared. So that's going to be -2 over 1 squared, which is negative 2. Okay, so at 2, it's negative 2. Okay. Let's try 3. 3 is going to be negative 3 over 3 minus 1 squared. Whoops. Okay, so that's going to be negative 3 over 3 minus 1 is 2. 2 squared is 4, so negative 3/4. Negative 3/4. All right. So this is pretty clear that this graph is just going to be like this, because like I said, it will only cross the horizontal asymptote once. So then everywhere else is just kind of being drawn to the asymptote. If you're not certain, then you can always just check on decimals to make sure that your graph is right, but this is the right graph. Okay, range for this one is going to be a little bit tricky, so you pretty much can't figure out where the highest point is unless you have decimals to help you. But if you did check on decimals, the highest point on this graph is at 0.25, which is 1/4, and that was at -1. That happens to be my highest point. So this is the kind of graph where the range is going to be optional on the test for extra credit. All right, let's look at this one. The first thing, again, we want to do is factor. And hopefully you do recognize this thing as difference of cubes. If you don't realize it, then you're going to run into a lot of trouble not graphing through a lot of holes. All right, so let's go ahead and factor. So remember SOAP. Same, opposite, always positive. Same means the same sign. Opposite means opposite sign from the original. Okay, so we're always talking about from the original. Always positive. The first one is going to be x and 1. It's exactly this and the cube root, basically the cube root of those terms. The second one is going to be x squared, and then you multiply AB together, so it's x, and last one is going to be b squared. Denominator is much easier to factor. Okay, so we can see that cancels, and we're going to get a reduced function of x squared plus x plus 1 over x plus 1. Don't kill cats here, and you cannot factor anymore. All right, let's look at the domain. X is not equal to plus minus 1. Vertical asymptote, only the reduced function, so x equals -1. Looking at the degrees for horizontal asymptote, the top is bigger than bottom, so none. Hole, okay, there is a hole at 1 because that cancels. We need to figure out the y-coordinate, so we're going to plug 1 in here in this function. So 1 squared plus 1 over 1 plus 1. That is 3/2. Okay, x-intercept is when you look at the reduced function and make the numerator 0. So make this 0. But like I said, it's not factorable. Since it's not factorable, and if you force factor it, basically by quadratic formula, you're going to get imaginary numbers. So this is none. There's no x-intercept. You can, we could go ahead and try it and make the numerator 0. And when you try to solve, hopefully you realize it's not factorable. You'll have to use quadratic formula. When you do, the radicand of a radical is negative. It's going to be imaginary. All right. Y-intercept is when x is 0. So 0, 1. You might be tempted to ask me, or just kind of have a question, is it the function before or after? The answer is, it doesn't matter. If you put in 0 for x in both of the function, you're going to get the same y-intercept, so it doesn't matter. All right, we got everything we need to graph. We have a vertical asymptote at x equals -1. We have a hole at 1 3/2. We have a y-intercept at 0, 1. No horizontal asymptote. Okay, so This again is not telling us too much. We're going to have to put in some numbers. I'm going to put in something on the left. So let's do -2 and -3. And some on the right, so maybe 2 and 3. Okay, now the question is, where do you put this number in? Do you put it in here or you put it in here? The answer is, again, it doesn't matter. Because for those of you who are really curious, this cancels. So then if you put it in either one, you're going to get into the place where this cancels. So then it really doesn't matter which one you put in. So, let's see, which one is easier to do? I'm going to put it in the reduce function because the numbers are going to be smaller. Okay, -3 squared plus -3 plus 1 over -3 plus 1. That is 9 minus 3 plus 1 over -2. That is 7 over -2. So -3.5. -3.5. Okay, down here. All right, -2. -2 squared plus -2 plus 1 over -2 plus 1. 4 minus 2 plus 1 over -1. That is -3. -3. Okay, I'm not quite sure how this graph is going to look like. I think I'm going to plug in one more number. -1.5. Let's do -3/2. Okay, -3/2 squared plus -3/2 plus 1 over -3/2 plus 1. Okay, don't be too scared by the fractions, just do it. 9 over 4 minus 3 over 2 plus 1 over -3/2 plus 1. That's -1/2. We need common denominator. So 2 over 2 here, 4 over 4 here. That is 13 minus 6 is 7. 7 over 4 over -1/2. So that is 7 over 4 times -2. Cancels, so that is -7 over 2. -7 over 2 is 3 over 5. Sorry, 3.5. Okay, then it looks like the graph is gonna look like this. Since both sides to -2 are going down, I'm gonna predict that the graph is just gonna go down. The graph is not gonna go like this. That is not a typical graph. So this graph is probably right. It's gonna go down like this. You can, again, you can always double check with decimals to make sure your graph is correct. All right, let me check to see what is going on at 2 and 3. Sorry, this is getting pretty messy, so let me write those down here. At 2 is 2 squared plus 2 plus 1 over 2 plus 1. So that is 4 plus 2 plus 1 is 7 over 3. 7 over 3 is about 2 and 1/3. 2 and 1/3. Okay, 3. 3 squared plus 3 plus 1 over 3 plus 1. So that is 13 over 4. 13 over 4 is about 3 and 1/4. 3 and 1/4. Alright, so this is turning out to be quite weird. So I'm gonna put in just one more point, double check. 0.5. So 1/2. 1/2 squared plus 1/2 plus 1 over 1/2 plus 1. So that's 1/4 plus 1/2 plus 1 over 1/2 plus 1 is 3/2. Again, common denominator, multiply by 2 over 2, multiply by 4 over 4. This gives me 7 over 4 over 3/2. So 7 over 4 times the reciprocal, 2 over 3. That cancels, so 7 over 6. 7 over 6 is slightly over 1. Okay, slightly over 1. That means the graph is going back up. So that's a little strange. The graph is probably going to look like this. Okay, double check on decimals, and we are correct. All right, range. Without decimals, it's almost impossible to find the points. Your graph is splitting. So there's a part that's below, and there's a part that's above. So then your range is actually going to be wherever the highest point on the bottom is. It turns out to be that point right here. This is the highest point of the bottom portion, and this is the lowest point of the top portion. So then your range is actually going to be y is less than or equal to -3, and y is greater than or equal to 1. This is a very, very hard problem. So this is kind of, make sure you know how to do this kind of problem so you can be prepared for the test. All right, now we come to the easy kind of questions. Let's go ahead and have you pause the video, try this, and then come back and double check your answers. All right, so you want to kind of double check your points against mine at this time. Just the analysis part, at least you have all those filled out. add. All right, so please take a look on for your graph. Once you put in the vertical asymptote and the horizontal asymptote and the y-intercept, there's just not much to figure out how this graph looks like. So you do want to put in a few points. You can see that at -1 and 1, the graph goes lower than the y-intercept, so this graph is going to go down. And then the other 2 points tells you kind of which quadrant or which section the rest of the graph is going to be in, and then you just draw it like as if the graph R is going towards the asymptote. All right, this range again. So let's say that this truly is the highest point of the lower section. Then we can say that this graph is not going to go above or equal to that point. That point is the y-intercept, so -1/5. And then I have a top portion of the graph that is staying above the horizontal asymptote, so I can say that y is greater than 2.